Aristotelian conceptions of motion. Aristotle's views on motion. Aristotle's views on motion was based on his observation, which made his idea acceptable and stood for many years. Motion is an object change in positions with respect to time. According to Aristotle, motion can either be a natural motion or a violent motion. Aristotle's views on motion are complex and multifaceted, forming a cornerstone of his natural philosophy. He believes that motion or change in any form was fundamental to understanding the universe. His idea, explored in his work Physics, are still debated today, highlighting their enduring influence on scientific thought. Natural motion. Based on Aristotle, natural motion occurs when an object moves and returns to its natural state depending on the positions that object is made of. An object made of material similar to Earth will return to Earth, or an object that is similar to air will return to the air. Natural motion is motions that comes from the natures of an object. These movements needs no external cause to occur. Example, heavy bodies naturally moves towards the center of the earth. Therefore, falling is a natural movement. The natural movements of object is one of the properties of an object. Violent motion. In contrast to natural motion, violent motion occurs when an object moves after an external force, such as pushing or pulling, is applied to it. No motion will take place unless there is a mover in contact with an object. Violent motion, by contrast, is motion contrary to the natures of the object and requires an external force in order to occur. Most motion are of these types, as stone thrown into the air moves and a violent motion against its natural and therefore requires for in order to cause to it move. Vertical motion. Aristotle believes that the vertical motion of an object depends on the kind of elements that made up the object. He believed that object could be made up of earth, water, air, or fire. Object made up of earth moved down because the ground was their natural resting place. Vertical motion refers to the movement in an upward or downward direction within highly elongated plasmas, such as in the context of the KT2 experiment, where it is primarily controlled by passive stabilizer and control coils to maintain stability. Horizontal motion. Unlike the vertical motion, Aristotle explained that horizontal motion is caused by force. This force is what Aristotle referred to as the impetus. According to him, an arrow moving in a horizontal direction will continue to move forwards as soon as it is released from a bow due to the force of air pushing the arrow from behind. Horizontal motion is defined as a projectile motion in a horizontal plane depending upon the force acting on it. For a short distance, the vertical and horizontal components of a projectile are perpendicular and dependent of each other. Projectile motion. Aristotle also tried to explain projectile motion. He believes that projectiles move parallel to the ground until it was the objective time to fall towards the ground. For example, a cannonball fired at a certain angle was given an initial force, an impetus, but his force would eventually disappear, and the stone would move back to its natural place, which is the ground. Projectile motion is the motion of an object thrown, projected, into the air when after the initial force that launches the object air resistance is negligible and the only other force that object experience is the force of gravity. The object is called a projectile and its path is called its trajectory.
Galilean conception of motion. Galileo's views of motion: 1. Vertical motion. 2. Horizontal motion. 3. Projectile motion. Galileo believed that the vertical motion of object was downward due to gravity. Unlike Aristotle, he believed that objects fall at the same rate even if they have different weight. According to him, in the absence of air resistance, objects would fall not depending on their weight but depending on the time of fall. Vertical motion. For example, without any air resistance, a 1 kg and a 10 kg object will fall on the ground at the same time considering they are released from the same height. Vertical motion. Galileo also noted that if an object encountered a resistive force from a fluid greater than or equal to its weight, the object will slow down and move uniformly until it stops. Considering a stone dropped in this ocean, the stone will sooner or later travel at a constant speed until it reaches the bottom of the ocean and stops. Horizontal motion. Galileo explained horizontal motion in such a way that an object in motion independent will continue to be in motion. In contrast to Aristotle, he noted that an external force is not necessary to maintain horizontal motion. Most of Galileo's ideas came from his thought experiments. These were done only by thinking about the situation in the experiment and analyzing the possible outcomes, so no actual experimentation were done. Horizontal motion. Independent horizontal motion, however, is not evident in nature. Friction exerted by the ground or road surfaces will eventually slow down an object. Air resistance in the atmosphere also impedes motion. For example, if a ball is pushed on road surface, it will roll for some time before it will come to a stop. Horizontal motion. Push on the ball. Ball rolls forward. Friction resists rolling. Galileo described the projectile motion as the combination of horizontal and vertical motion. He referred to this combination of motion as compound motion. Galileo explained the vertical motion in the form of gravitational acceleration, and horizontal motion occurs at the same time. These motions are independent of each other and are always perpendicular to each other. Projectile motion.
Galileo inclined plane experiment. Galileo idea about falling object. Galileo was fascinated by the behavior of falling objects. He wondered if two objects of different mass were dropped at the same height, which will hit the ground first. To answer this, he devised a thought experiment in which two objects with unequal weights were dropped with very minimal earth resistance affecting this object. He postulated that the object, regardless of the weight, would hit the ground at the same time. Based on this observation, Galileo knew that following objects increase their speed as they go down. This change in speed per unit time is called acceleration. He postulated the object fall with uniform acceleration. Galileo
idea about falling objects. Galileo experimented with inclined planes. He even reached out equipment to measure the change in speed of falling objects. Galileo was enabled to investigate acceleration touch inclined plane by this touch experiment. He used a ball and inclined plane with a small scope so that the ball accelerated more slowly than an object in free fall. This experimental design allowed him to determine the relation between the time and the distance traveled by an object. During this experiment, Galileo saw multiple observations. First is that the velocity of the ball increased as the ball moved down the incline. A ball rolling down an inclined plane increases its speed after every time interval considered. From example, the speed of rolling ball was found to increase by 2 ms every second. This means that the rolling ball would have to follow speed from the velocity of the ball increased as the ball moved down an incline. Second, the total distance traveled by the ball depends on the square of the time. The distance traveled by the ball along the incline is a factor of the square of time it has traveled. The total distance traveling by the ball dependent on the square of the time. Third, as the inclined plane became steeper, the acceleration of the rolling ball increases. Increasing the inclination of the plane increases the rate at which the velocity of the ball changes with respect to time. Thus, its acceleration increased. The inclined plane became steeper, the acceleration of the rolling ball increased 2 meters per square second, 6 meters per square second, 9.8 meters square second. Lastly, the ball reached its minimum acceleration when the inclined plane was positioned vertically as if it was simple falling. Placing the ball directly perpendicular to the surface, which the highest inclination make it exhibit free fall. This makes gravity the only force acting of the ball, producing an acceleration of 9.8 meters square second.
Comparing Aristotelian and Galilean views on motion. Galileo versus Aristotle. Aristotle and Galileo. Aristotle, a Greek philosopher, first explained the concept of motion. Based on inductive reasoning, he believed that objects tend to move depending on what element they are mostly composed of. This belief was accepted for centuries until Galileo. Galilei, an Italian scientist, explained the concept of motion based on his thoughts and actual experiments. Aristotle says that the heavier things are, the quicker they will fall, whereas Galileo felt that the mass of object made no difference to the speed at which it fell nearby. Aristotle believed that the motion of an object depends on the element that mainly compose it. In this way, an object will always tend to return to its natural state, such that an object composed of mostly each materials will always go back to the earth. Just as Aristotle described the motion of an object based on its element, he postulated that the vertical motion of an object is in the direction of its natural place. This suggests that objects with more air components tend to go up in the atmosphere. Objects with more earth components will tend to go down on the earth, etc. Aristotle's views of motion. Aristotle's idea of vertical motion, in which fire and air rise up while water and earth go down. Aristotle's views of motion. Object moving horizontally will definitely stop when an impetus, as Aristotle described, is not present. He believed that object will only continue moving horizontally when enough impetus is present. Aristotle's views of motion. Air resistance. According to Aristotle, an arrow over forward soon as it released from the bow because of the air resistance pushing it. Furthermore, based from his observation, Aristotle taught the object fall at rate depending on its mass. With this he taught the heavier object would reach the ground faster than lighter ones when known at the same height and time. Lastly, Aristotle viewed projectile motion as propelling an object horizontally with an impetus. This impetus, when lost, will immediately stop an object's horizontal motion. Furthermore, the object will then fall straight to the ground like a free-falling object. Aristotle views of motion. The path of the motion of a projectile based on Aristotle's idea. Galileo's views of motion. Galileo stated that all objects move depending on the forces acting on it, and also established the idea the object root in space will move downward because of the gravitational pull acting on it. All objects, regardless of elemental composition, will fall down when thrown. Galileo also discussed that an object moving along a horizontal path will continue moving unless acted by an external force. Hence, the motion of an object will not stop unless something stops it. Galileo's views of motion. Ball rolls forward. Push on the ball. Friction resists rolling. The movement of the ball on a road surface is affected by the friction on the surface, making the ball slow down and stop. Galileo also found that regardless of mass, objects fall at the same rate. In the absence of air resistance, objects of different masses will reach the ground at the same time when thrown at the same height. Galileo's views of motion. According to Galileo, a 1 kilogram object will fall on the ground at the same instant as the 10 kilogram object, provided that they are rapid at the same height. Galileo viewed projectile motion as the combination of horizontal and vertical motion, acting simultaneously on the object. He explained that when a cannonball was fired, the path of its motion can be determined by considering the horizontal and vertical components of its motion. The path that he was referring to is the trajectory. Normally, an object trajectory can be perceived as a curved path. Galileo's views of motion. Galileo's theory. Aristotle theory. The comparison between Aristotle and Galileo path of a cannonball under projectile motion. Aristotle versus Galileo. Motion and composition. Aristotle, the natural motion of an object is to return to its natural state based on its composition. Horizontal motion. The impetus is needed to sustain the horizontal movement of an object. Galileo Galilei. The motion of an object does not depend on its composition. Force is not needed to sustain horizontal motion. Vertical motion. The vertical motion of an object depends on the kind of element that makes up the object, which can be each water, air, or fire. Relationship of mass and speed. Heavy objects fall faster than lighter ones. Galileo Galilei. The motion of an object thrown in space was downward due to gravity. The speed of the object as it falls does not depend on its mass. Its air resistance is negligible. Projectile motion. A projectile moves parallel to the ground until the impetus is lost and object will fall straight toward the ground. A projectile path is the combination of horizontal and vertical motion of an object. Aristotle employed inductive deductive logic in explaining the motion of objects based on their elements. 2. Galileo performed through and actual experiments to determine the behavior of objects under vertical, horizontal, and projectile motion. Identify whether the concept idea came from the Aristotle or Galileo. 1. An impetus is needed to sustain horizontal motion. 2. Free-falling objects have uniform acceleration. 3. An object composed of earth materials will tend to fall back to earth. 4. The natural motion of an object is to return to its natural state. 5. Projectile motion. Describe the vertical and horizontal motion of objects.